For the first time in all of recorded astronomy, the sun blinked. Not literally, it didn't dim, it didn't flare, but something passed before it. Something small, cold, and impossibly far from home. And for a brief moment in October 2025, every telescope on Earth lost sight of it. That object was 3IATLAS, a visitor from the space between stars, neither born of our system nor bound by its rules. It came out of the dark, like a question without an answer, sliding silently into the plane of our planets, cutting across the orbits of Mars, Venus, and Jupiter with almost intentional precision. And when it reached its closest point to the sun, the moment astronomers call perihelion, it disappeared behind the solar glare. For 16 days, humanity went blind. We could track nothing, see nothing, and in that blindness, imagination took over. Before we dive deeper, if you love stories where science meets mystery, where the universe itself feels alive, consider leaving a like. It helps others find their way here too. No pressure, just a quiet thank you for keeping curiosity alive. 3IATLAS wasn't supposed to exist. When it was first detected by the Asteroid Terrestrial Impact Last Alert System Atlas in April 2025, it didn't fit anything in the catalogs. Its orbit wasn't elliptical like a comet from our own Oort cloud. It was hyperbolic, meaning it came from interstellar space, just like Oumuamua in 2017 and Borisov in 2019, but this one was different. It was brighter, denser, more volatile, and strangely more predictable, as if something about its trajectory wanted to be seen. Astronomers across the world began to track it: Hawaii, La Palma, Mauna Kea, the VLT in Chile, even amateurs with backyard telescopes. Every night the data came in faint streaks of light velocity measurements, tail-length albedo curves, and one by one they noticed something unnerving. The object was following the ecliptic, the thin, invisible plane where all our planets orbit, almost perfectly aligned. Statistically, the chance of that alignment happening by random interstellar entry was less than 0.2%. The headlines wrote themselves, "Too perfect to be chance." The alien probe hypothesis returns. But data isn't conspiracy. Data is just data until you can't explain it. By July, as 3IATLAS drew closer to the inner solar system, telescopes began to see something else. Its tail was wrong. Instead of streaming away from the sun, pushed by solar radiation and solar wind, it appeared to angle toward it, an anti-tail. To most astronomers, it was an optical illusion, a line-of-sight effect. But a few observers using the Nordic Optical Telescope in the Canary Islands confirmed the impossible. The anti-tail was real. Jets of gas were pushing toward the sun. Physics didn't add up, and that's when the tone changed. No longer just an interstellar curiosity, 3IATLAS became a global phenomenon. Theories flooded in solar magnetic interactions, CO2 outgassing on the comet's night-side microjet rotation, or something more. A few voices louder than others suggested the unthinkable: what if it's not natural? At Harvard, Avi Loeb, already famous for defending the possibility that Oumuamua was artificial, gave interviews hinting at another cosmic messenger. He didn't say it was an alien probe, only that it couldn't be ruled out. He gave it a 40% probability, enough to ignite the internet. Reddit threads grew into communities of hundreds of thousands. Twitter became a war zone of skepticism and belief. TikTok, YouTube flooded with videos claiming NASA was hiding the truth. And somewhere in that storm, the real scientists kept watching. By mid-October, 3IATLAS was within 0.4 AU of the Sun. It passed near Mars on October 3rd, close enough that orbiters like ExoMars Trace Gas Orbiter could photograph it. Then it curved inward, a silent stone arcing into fire. And that's when Earth lost its view. From October 21st to November 6th, the comet was hidden behind the sun. Every ground-based telescope went blind. No observatory could see through the glare. The timing perfectly coinciding with its perihelion seemed too cinematic to be coincidence. Right at the moment of truth, the entire planet lost its line of sight. For astronomers, it was maddening. For conspiracy theorists, it was confirmation. Was it hiding? Did something happen behind the sun, something we weren't meant to see? The logical explanation was simple orbital geometry. Solar conjunction happens all the time. Mars, Venus, even asteroids go behind the sun regularly. But logic isn't enough when mystery feels alive. The human mind doesn't tolerate silence. If we can't observe, we imagine. And in that 16-day blackout, imagination filled the void. What if it turned? What if it deployed something? What if the sun wasn't just a light, but a signal? The internet buzzed with those whispers. Meanwhile, spacecraft coronagraphs like SOHO's LASCO C2 and C3 and the Punch polarimeter continued to capture data. The images showed a faint blur, a streak barely visible in the coronal haze. No sudden flares, no disintegration. But the blur was there, consistent, measurable, alive. Yet, the absence of anomaly itself became suspicious. If they show us nothing, maybe that's the proof something did happen, one viral post claimed. A perfect paradox, evidence of normal behavior became evidence of cover-up. And as the sun's glare swallowed the object, one thing became clear. Whatever 3IATLAS was, it had captured something no comet ever had before, the imagination of an entire species. The sun blinked. We blinked back. And when the light returned, nothing in the sky or in us would be quite the same. It came from a place no map had ever named. Not from the Oort cloud, not from any known stream of long-period comets, but from a deeper silence, the interstellar dark between suns. Before 3IATLAS, only two objects like it had ever been seen. First, Oumuamua, the slender shard that slipped through our solar system in 2017, turning without jets, reflecting light like metal. Then, Borisov in 2019, more ordinary, a dusty, icy traveler behaving like every other comet, but born elsewhere. And then years later came this one, different, heavier, brighter, stranger. At first, no one noticed its arrival. The sky that night in April 2025 was ordinary. The Atlas Survey Telescope in Hawaii, running automated sweeps scanning for near-Earth threats. A single streak of light appeared on the data feed, faint, curved, oddly fast. The algorithm flagged it. The humans didn't, not yet. Only after the second pass, when its position no longer fit any known orbit, did the name appear in the system, 3IATLAS. Third interstellar object ever detected. It didn't belong here, and yet it moved as though it knew exactly where here was. Its incoming velocity, 29.5 kilometers per second relative to the sun. Its eccentricity, 1.08, too high for capture, too precise for chaos. Most comets wander. This one arrived with intent. Scientists at JPL replayed the data again and again. One of them whispered, though no microphone caught it, a thought that would echo across forums for months. How does something travel light years and still find the narrow plane of our planets? Have you ever looked at the night sky and wondered how anything so vast could feel deliberate? Back at Mauna Kea telescopes locked on the new coordinates. Within 48 hours, more than 200 observatories worldwide confirmed it was inbound and on a perfect ecliptic alignment. Its tail was still invisible, its coma dark. It looked like a solid object reflecting sunlight coldly, like polished stone. The first spectral readings came days later. CO2, water ice, trace hydrocarbons, nothing alien. Yet the ratios were wrong. Too much carbon dioxide, too little dust. It was as if the comet had been stripped, purified, traveling naked through space for eons. Some called it a fossil, others a messenger. By May, the public began to notice. Minor astronomy channels uploaded grainy footage, a tiny pixel moving across a field of stars. The caption read, "We're watching something older than our sun." The comments filled instantly. Fake, NASA distraction, proof of life. The debate was alive again. But in laboratories and observatories, the tone was quieter, more reverent. It wasn't about aliens, it was about improbability. Statistically, interstellar objects should cut through the solar system at random angles. There is no cosmic traffic lane, no gravitational highway that connects star to star. Yet, 3IATLAS approached from almost the same direction as Oumuamua within a few degrees. Two visitors years apart, traveling similar routes. Coincidence? Or are we standing near a path the universe uses more than once? Data continued to flow. No bright outgassing yet. No typical comet tail. And still, the object brightened not like reflection, but like awakening. Spectrographs showed subtle fluctuations, periodic flashes every 57 hours, as if it rotated, revealing something different on each side. In one frame it was gray and dull. In the next, it shimmered faintly blue. Was it ice catching sunlight or something under the ice responding to it? Weeks passed. The orbit was plotted, its close approaches predicted. In late September, it would pass near Mars, close enough for orbiters to attempt imaging. And after that, its descent toward the sun. Across the scientific community, something stirred not fear, but humility. To witness something that had drifted between stars for millions of years, and to know it chose somehow to pass through our fragile system. It felt like standing on a quiet shore, watching a ship appear from fog. If you were looking up that night just above Cassiopeia, you might have seen it too. A single moving star, faint, patient, ancient. And maybe for a second you would have felt what the astronomers felt, that strange pull between awe and disbelief. 3IATLAS was not the first to visit us, but it might be the first we truly paid attention to. And as it moved closer, the questions grew louder than the answers. Where did it come from? How long had it been traveling? And the one that kept echoing in quiet observatories and darkened rooms, was it really alone? Because sometimes in the silence between radio static, they swore they heard something else. A faint whisper, deep and steady, hidden beneath the noise like a pulse. The path was perfect, too perfect. When 3IATLAS's orbit was first plotted, scientists expected chaos, a wild slingshot curve through the solar system, a cosmic drive-by that barely grazed the inner planets. But what they found instead left even the most skeptical astronomers silent. The trajectory wasn't random. It threaded between Mars, Venus, and Jupiter like a needle passing through moving rings, grazing gravity wells, but never falling into any. Each planet's pull altered it just enough to keep the curve stable. That shouldn't happen, not by accident. Every object we've ever seen from beyond our system enters like a drunk meteor, one researcher at JPL said quietly. This one moves like it rehearsed. Have you ever seen something so precise it made you uneasy? When the simulation finished rendering, a single golden line traced the orbit across the screen. The planets moved their own paths, glowing faintly. 3IATLAS wove between them like a pattern dipping near Mars, brushing Jupiter's magnetic field, then bending inward toward the Sun. The probability of such alignment, if chosen at random, was less than 0.2%, less than 1 in 500, yet here it was real, glowing on a monitor in Pasadena. Astronomers double-checked the math. They adjusted for observational error for gravitational perturbations for the slight influence of solar wind. The numbers stayed the same. The object wasn't just passing through, it was sampling the solar system. At first, they laughed it off. Sampling sounded too anthropomorphic, too much like intention. But the deeper they looked, the harder it was to dismiss the symmetry. 3IATLAS trajectory allowed it to pass close enough to Mars to be observed, close enough to Venus to measure solar radiation pressure, and close enough to Jupiter to feel the outer reach of its magnetosphere, all within months. If it had wanted to understand a star system, it couldn't have chosen better. Of course, that was absurd. Rocks don't plan. Ice doesn't calculate. But even in the absurd, there was precision, and precision demands explanation. Could the sun itself be guiding it, someone proposed? The idea wasn't mystical, it was mechanical. Photogravitational effects. The delicate dance between light pressure and gravity can subtly shape orbits, but not this precisely. Not across multiple planetary passes. By late July 31st, Atlas was inside the orbit of Mars. Its speed increased. Its brightness pulsed again every 57 hours like clockwork. No dust jets, no visible rotation axis, but that rhythmic flicker persisted. Some said it was coincidence. Others started calling it the heartbeat of a traveler. If you could have watched it from space, it would have looked almost alive and ember, drifting in vacuum, growing brighter each time it faced the sun. At the European Space Operations Center, teams compared 3IATLAS flight path to those of known comets. The data refused to fit. Natural comets always exhibit measurable perturbations, jets of gas that act like miniature thrusters, altering their course unpredictably. But 3IATLAS's orbit remained smooth, no jitter, no deviation beyond gravitational norms. It was following the mathematics of perfection. That was what unnerved them most. By August, observatories began to lose sight of it during daylight hours. It was moving into the sun's glare, soon to vanish behind it for weeks, an event called solar conjunction. Normally, this would be unremarkable. Venus disappears behind the sun every 19 months, Mars every 26. But for this object, the timing was uncanny. Its closest approach to the sun, perihelion, would occur exactly during conjunction when Earth could not observe it. The universe had given humanity 4 months to watch, and then just as it reached its most critical moment, it slipped behind the very star that blinded our view. Think about that. After traveling for millions of years through distances beyond imagination, it arrived in our neighborhood, and at the moment of closest encounter, the entire planet had to look away. It was almost poetic. At JPL, someone muttered, "If you wanted to do something unseen, that's when you do it." No one laughed. From October 21st to mid-November, Earth would be blind. Ground telescopes useless. Space telescopes overwhelmed by sunlight. Only a few solar observatories like SOHO and Stereo could glimpse the region indirectly through coronagraphs designed to block out the sun. But the resolution would be poor. If 3IATLAS changed, fragmented, flared, or vanished, the details might never be captured. The idea unsettled everyone. Astronomy is built on seeing, and suddenly humanity was forced to wait. In the public sphere, speculation ignited. What would happen while the comet hid behind the sun? Would it survive the heat? Would it disintegrate like Ison in 2013? Or would something impossible occur? something only the sun could reveal. Scientists stayed measured, cautious. They reminded the public that comets pass behind the sun all the time, but privately, many admitted the coincidence was eerie. How do you calculate the odds that an interstellar object, the third ever discovered, would time its perihelion to coincide perfectly with Earth's observational blackout? Statistically infinitesimal, emotionally unsettling. By September's end, NASA released a final pre-conjunction trajectory update. The data showed a flawless curve toward the sun, cutting through the plane of our solar system like a deliberate incision. One headline read, "The comet that knows where it's going." That night, millions of people looked up, some with wonder, some with unease, all waiting for the sky to blink again. Weeks later, in a conference room filled with stale coffee and flickering monitors, a group of astronomers reviewed the last images before blackout. The comet's coma was faintly visible, smooth, symmetrical, almost artificial in its perfection. "Maybe it's just geometry," one of them said. Another shook his head. "Maybe geometry's trying to tell us something." The room fell silent. Have you ever waited for something you couldn't see but knew was happening anyway? That's what the world did. We waited. Online, the theories multiplied. Alien probe, self-replicating nanovessel, harbinger comet. Every day, new videos appeared, some earnest, some desperate for views. But underneath the noise, a quieter truth lingered. The real story wasn't what we imagined the comet to be. It was what it made us realize about ourselves. That for all our telescopes and technology, we are still children standing under a vast sky, guessing at the movements of things older than our species. For all our precision, we still look up and wonder if the universe notices us back. By early October, the last confirmed images arrived from the Solar and Heliospheric Observatory. A tiny white speck moving against the backdrop of the sun's corona. No flares, no explosions, just motion. And then the screen went dark. For 3 weeks, humanity could only wait. No updates, no images, just the knowing that somewhere beyond the glare, the traveler was passing through its closest point to the star that had given us life. Some people prayed. Others scrolled. A few simply went outside each night knowing they couldn't see it, but watching anyway, as if presence alone could bridge the distance. In those nights of blindness, something strange happened. Search trends spiked not for alien comet, but for how far is the sun? How long does light take to reach us? How big is space? For a brief moment, curiosity outshone fear. And maybe that was the real miracle. Not the comet. Us. The way one moving point of light could make an entire civilization stop and ask where it truly stood in the vastness. When the first post-conjunction data finally arrived, scientists rushed to compare it. Position perfect, brightness stable, trajectory unchanged. The object had passed through perihelion without incident. No signs of disintegration, no thrust, no deviation. Physics, at least for now, had held. And yet, some part of the world seemed disappointed. We wanted the extraordinary. We got the natural. But sometimes the natural is extraordinary because it survived where so much else would have burned. 3IATLAS had come closer to the sun than any interstellar object in history. It should have fractured. It didn't. Instead, it emerged brighter, clearer, almost serene, a wanderer that had faced a star and lived to tell about it. As the data flowed in a single truth began to crystallize across every screen, every observatory, every sleepless room of scientists and dreamers alike. The universe doesn't owe us meaning, but sometimes it gives us patterns enough to make us wonder. And wonder in the end is how discovery begins. It happened quietly. No explosion, no warning, just light. The kind of light so fierce that it erased itself. On October 21st, 2025 at 14:06, UTC Earth lost sight of 3IATLAS. For the first time in months, every telescope, every lens, every eye turned toward a single point and saw nothing. The comet had slipped behind the sun, and the world went blind. It's strange how silence can feel louder when you've been listening for too long. For 4 months, humanity had tracked this object across the sky, every flicker, every pulse, every spectral whisper. Then suddenly, it was gone. The sun, our oldest companion, became a wall. Inside the Solar and Heliospheric Observatory, the last image lingered on screen. A grainy white smear, a fading echo, then static. Signal lost, a voice announced flatly. The room didn't answer. The hum of the servers filled the space where sound should have been. Somewhere deep in the observatory's control bay, someone whispered, "It's behind the light now." And for a few moments the world held its breath. When the blackout began, every observatory on Earth faced the same truth: nothing more could be done. You can't outwatch a star. Even our most advanced coronagraphs, SOHO Stereo Solar Orbiter, could only see the ghost of the event. The thing about blindness is that it invites imagination. When we can't see, we start to dream. What happens when a comet from another star brushes the face of our sun? Does it burn? Does it fracture? Or does something else awaken inside it? That question became an obsession. Within hours, the forums were alive again. Did it survive? Will it slingshot out or fall in? Did it change? The scientists waited for data. The dreamers waited for proof. And the rest of the world waited for a story. In a darkened office at JPL, a small group of astronomers watched the sun's telemetry graphs. Solar flares, radiation bursts, solar wind pressure all normal. No anomalies, no unusual spikes, and yet, one small signature appeared in the background noise, a rhythmic pulse, not strong enough to be a signal, not random enough to be ignored. Every 57 hours, the same pattern as before. Rotation, someone suggested. Echo, another replied softly. No one spoke after that. Outside the lab, Los Angeles was evening. The city lights shimmered like static below the mountains, and above them, the sun sank behind a haze of gold. Somewhere out there, behind that brilliance, the visitor was passing by, and none of us could see what it was becoming. Have you ever felt the fear of missing something extraordinary right when it's closest? That was the feeling that blanketed the world. Astronomers called it the window of invisibility. Poets called it the blink. And online it was simply the blackout. During those 3 weeks, the silence turned electric. Social media flooded with theories. It's maneuvering, it's feeding, it's communicating through the sun. Someone claimed to detect radio bursts from the far side. Another claimed NASA had shut down live telemetry. Neither was true. But truth had stopped being the point. In the absence of vision, imagination became the loudest voice in the room. And imagination, once unleashed, doesn't obey reason. Across the planet, videos appeared, fake press conferences, fabricated NASA emails, doctored telemetry graphs. All of them shared one phrase: something changed during the blackout. Meanwhile, in real laboratories, real people stared at blank screens waiting for real data. In those weeks of blindness, a strange shift occurred. The object became more than an astronomical curiosity. It became a mirror. For scientists, it reflected uncertainty, a reminder that even in the age of AI and quantum sensors, there are still corners of the universe we can't watch. For philosophers, it reflected the fragility of knowledge, how one missing piece can make the whole picture feel incomplete. And for everyone else, it reflected something even more primal, the fear that the universe might be moving without us, the fear of not being invited to witness. In Japan, the Subaru telescope dome remained open through the blackout. not to observe, but to listen. A team there turned their instruments toward the sun's periphery, hoping for a reflection off solar wind particles. The result was mostly noise, but buried within that noise was something peculiar, a dip in polarization intensity that repeated every few days. Maybe it was nothing. Maybe it was everything. They logged it carefully, time-stamped it, and said nothing publicly. Until they had data, speculation would only feed the storm. But the human mind doesn't like waiting. In those days of blindness, time stretched. A minute felt like an hour, a day, a month. And the imagination of millions filled the gap that science could not. The blackout became its own kind of ritual. Every night people stepped outside and stared toward the sun's direction after dusk, as if searching for the echo of what they could not see. Children asked their parents if the comet was alive. Old astronomers whispered that this was what wonder used to feel like. The irony was that 3IATLAS hadn't vanished at all. It was still there, tracing its perfect arc around the sun, obeying gravity with quiet precision. The blindness was ours, not the universe's. When you think about it, that's always been the truth. By early November, the first coronagraph data began to trickle in from the European Space Agency. Low resolution, overexposed, but unmistakable. The comet was emerging from behind the sun intact. Its brightness was stable, its trajectory unchanged, its heartbeat still pulsing faintly in the data. It had survived. The relief across the scientific community was almost physical. Months of tension broke in a single collective exhale. It hadn't burned. It hadn't vanished. It hadn't done anything impossible. And yet, somehow it still felt miraculous, because the fact that it hadn't defied physics didn't make it less extraordinary. It made physics itself feel miraculous again. That evening, a quiet press statement from NASA read, "3IATLAS has successfully passed perihelion. Its orbit remains consistent with projections. Observations confirm natural behavior consistent with cometary activity." But between those words, "successfully passed," there was something profound. We had waited in darkness, uncertain, powerless, and now the world could see again. When the first clear post-conjunction image arrived, taken by the LASCO C3 instrument, scientists cheered softly. It wasn't dramatic, just a small white speck surrounded by faint haze, but it was proof that waiting had meaning. The image spread online within minutes. People zoomed in, enhanced, colorized. They captioned it with awe, jokes, disbelief. But beneath all that noise, one simple truth connected them for 3 weeks. The universe had kept a secret, and now it had whispered it back. In the following days, something changed in how people talked about 3IATLAS. The wild theories faded. The scientists spoke louder. The tone softened. Because the story was no longer about aliens or conspiracies. It was about patience, about how sometimes the universe asks us to stop talking and simply wait. And waiting for once had given us wonder. As November unfolded, the comet drifted outward again, cooling, dimming, retreating into the darkness that had birthed it. But the memory of its passage stayed behind, not just in data, but in people. The astronomers who'd spent nights staring at empty graphs said it best. Even blindness can teach you how to see. 3IATLAS reminded humanity that not all discovery happens in light. Some of it happens in the quiet, in the uncertainty, in the moments when all you can do is trust that the universe hasn't forgotten to surprise you. And maybe that's the real story of this blackout, not the comet, not the numbers, but us, the way we fill silence with imagination, fear, and hope, the way even in the dark we keep listening. Because sometimes the most extraordinary thing isn't what you see, it's what you keep believing is still out there. When the world could finally see again, the first thing we noticed was wrong. 3IATLAS had survived its passage behind the sun, yes, but something about it had changed. Not in brightness, not in color, but in direction. Its tail, the signature of every comet since the dawn of astronomy, no longer pointed away from the sun. It pointed toward it. For a moment, the scientists thought it was a data error, software glitch, imaging distortion, but it wasn't. Images from SOHO Solar Orbiter and the Nordic Optical Telescope all confirm the same impossible geometry. The dust tail of 3IATLAS extended toward the light, not away from it, and the rules of physics for a few days bent under the weight of that realization. Comet tails, in the simple language of the universe, always tell the same story. Sunlight and solar wind push dust and gas outward, forming luminous trails that stream away from the star. It's one of the first cosmic truths humans ever learned. But 3IATLAS was telling another story entirely. Its tail wasn't rebelling against physics. It was revealing a hidden layer of it. In the control room at the European Space Operations Center, the images were magnified until the pixels broke apart into glowing dust patterns. Silent gestures filled the air. Fingers pointed. Pens hovered mid-air. Nobody dared speak too loud, as if sound might disturb the impossible symmetry on screen. The anti-tail, a second stream of dust and debris pointing toward the sun, wasn't unprecedented. Rarely comets show this optical illusion when viewed edge-on from Earth, where perspective tricks the mind into seeing a reversed tail. But this wasn't perspective. This was physics acting in reverse. Spectral data from the LASCO C3 and C2 cameras showed denser dust near the comet's nucleus than in its outer flow, meaning the debris wasn't being pushed outward. It was falling back, drawn toward the sun like iron filings pulled by a magnet. It defied intuition, but not gravity. Some called it the solar riptide. Others named it the inward wind. In truth, it was a phenomenon long theorized, but never witnessed so clearly, a region of solar turbulence where charged particles moving slower than the comet's velocity created a drag field instead of a push. In other words, the comet had outrun sunlight. Imagine that, a fragment of interstellar ice older than our planet moving so fast through the plasma wind that it reversed the direction of its own shadow. Have you ever wondered what it feels like to move faster than the thing that defines you? The discovery rippled through every lab that still had eyes on the comet. Harvard, Caltech, ESA, JAXA all sent urgent requests for observation time. For 2 weeks, the world of astronomy became a single heartbeat, a silent race to understand what 3IATLAS had just done. In one dim-lit office, a young astrophysicist named Rena plotted vectors on a holographic model. The lines spiraled inward, forming an elegant shape like the arms of a galaxy folding back on themselves. Her supervisor leaned in, whispering, "Is that turbulence or interaction?" She didn't answer, because somewhere in her chest she already knew it was both. Interaction. Between motion and resistance. Between what moves and what refuses to move. Between the traveler and the light it crossed. Atlas wasn't disobeying physics, it was dancing with it. Across the internet, the term anti-tail became a sensation. Headlines screamed, "The comet that points at the sun, a cosmic mirror defying the laws of nature. NASA can't explain this yet." Videos flooded in diagrams, theories, hoaxes, but none could match the quiet truth of the data itself. The universe hadn't broken its rules. It had just reminded us how incomplete our understanding still was. At the Nordic Optical Telescope, a group of scientists stood under the cool twilight of the Canary Islands. They had been awake for 36 hours straight. No one complained. They watched the latest feed the comet glowing faintly blue, its strange tail curving sunward like a beckoning hand. Someone exhaled softly, and for the first time in days, a smile. "It's beautiful," one mouthed. Another nodded. "It's trying to tell us something." No words beyond that. Just the wind, the sea below, and the quiet hum of the telescope. The deeper they looked, the more the mystery unfolded. Dust grains moving inward weren't behaving randomly. They oscillated in fine arcs curving like wave patterns. Computer models recreated the motion, a resonance effect caused by oscillating CO2 jets and microparticle interference. Essentially, 3IATLAS had created its own field of reflection where gravity, sunlight, and sublimation all fought for dominance. At the center of that chaos, order emerged, a perfect symmetry between motion and collapse. The antitail wasn't defiance, it was harmony. Have you ever watched two opposing forces cancel each other and realized the result was beauty? That's what it felt like to watch 3IATLAS. It reminded us that not every contradiction needs resolution. Some just need to be witnessed. Meanwhile, deeper analysis began to reveal another clue. The gas composition near the nucleus had shifted. CO2 emissions were falling, but the hydrogen line from H2O vapor had increased. The comet was transforming. The heat of perihelion had turned its carbon dioxide ice into water, a rare chemical evolution marking the transition from interstellar cold to inner solar life, from stone to steam, from silence to motion. Every comet teaches something about time. This one was teaching us about change. As 3IATLAS continued outward, the anti-tail slowly faded. Its geometry softened the inward curve, dispersing into the solar wind until it disappeared entirely. But for those who had seen it, that image, the comet pointing toward the light, would never fade, because it meant something more than science could measure. It meant that even in the language of dust and radiation, the universe could still whisper paradoxes and trust us to listen. At a conference weeks later, when the data was finally published, a reporter asked a scientist, "So, did it break the laws of physics?" The scientist smiled gently. "No," she said. "It showed us where those laws still bend." Laughter filled the room softly, but behind it lingered awe. For centuries, we've used comets as omens of death, of birth, of change. Maybe this one wasn't a warning at all. Maybe it was a question. As the comet receded beyond the orbit of Venus, growing dimmer each night, astronomers logged their final observations. No anomalies, no miracles, just motion, the slow retreat of something that had brushed our world with its shadow and left us a story. 3IATLAS had entered from between stars, touched the sun, and rewritten our sense of direction. And in its wake, it left not fear, but curiosity. Sometimes what we call mystery isn't the absence of explanation, it's the presence of wonder. And sometimes the most meaningful discoveries aren't the ones that change physics. They're the ones that make us look up again, knowing the universe still has questions it hasn't asked aloud. By the time 3IATLAS drifted back into the visible sky, something subtle and far stranger had begun to unfold. The comet that had once defied the sun with a reverse tail was changing again. Its glow was no longer steady white-blue. It pulsed faintly, rhythmically, like the echo of a heartbeat lost in space. For weeks, telescopes from Earth, Mars, and the solar orbiter recorded the same anomaly gas emissions, fluctuating in patterns that no ordinary comet had ever shown. The chemical fingerprints told the story first. Less carbon dioxide, more water vapor. The ratio had flipped. It was as if 3IATLAS had decided to shed one voice and speak with another. In most comets, carbon dioxide drives the early activity. It vaporizes easily, creating the first jets long before sunlight can melt water ice. But 3IATLAS was an interstellar traveler, its crust hardened by ages of cosmic cold. The fact that CO2 was now fading meant something profound the surface had awakened. Solar heat had penetrated deep enough to sublimate the water trapped inside. Ice was giving way to vapor. Silence was becoming sound. Have you ever heard a truth change its language and realized it's still saying the same thing? That's what the scientists were witnessing, a frozen memory, learning how to breathe again. At the Mauna Kea Observatory, infrared spectra glowed like shifting fingerprints. Peaks rose and fell in slow cadence, tracing the comet's chemical evolution. Someone whispered, "It's teaching us how it dies." No one answered. Death in the language of comets is just transformation. Inside the control room, the atmosphere was reverent. Data streamed silently across screens, a symphony of decimals and wavelengths. In one corner, a researcher wiped condensation from her coffee mug, watching the graph's red line rise, water's spectral signature blooming like a pulse. Outside, the Hawaiian sky was clear stars, sharp and indifferent. Yet on those monitors, a grain of cosmic ice was rewriting what we knew about life and time. Back at JPL, a simulation played out on a massive curved screen. A digital comet spun slowly under virtual sunlight. Tiny jets flared along its ridges, each representing molecules of CO2 escaping, replaced by jets of water vapor. The director leaned forward. "It's like watching an atmosphere being born," he said softly. Around him, scientists nodded, silent, wide-eyed. They were watching chemistry behave like memory. What no one had expected was how precise the emission cycles were. Every 57 hours, the same interval as before, a fresh plume erupted from one hemisphere, timed perfectly with its rotation. It was no longer a coincidence. It was rhythm. The object wasn't just reflecting sunlight, it was answering it. Data from the European Southern Observatory confirmed its temperature fluctuations matched the comet's spin, almost exactly indicating active control, not in the conscious sense, but in the mechanical sense of balance. This wasn't chaos, it was feedback. In space, even dust learns to adapt. As 3IATLAS neared its outbound leg past the sun, its brightness steadied, its tail normalized, but the spectrum continued to sing. Carbon dioxide, once dominant, now lingered as a whisper. Water, fragile and fleeting, had taken the lead. To most, it was just another line of data, but to a few it meant something else entirely. The voice of the comet had shifted from alien to familiar. CO2 is the breath of lifeless worlds, dry, inert, eternal. H2O is the breath of possibility. When the ratio changed, so did our perception. The comet that once felt distant, unknowable, foreign, suddenly felt like kin. It was as if in crossing our sun, 3IATLAS had chosen to speak in a language we could finally understand. Have you ever felt the universe trying to meet you halfway? That was the feeling that spread quietly across the scientific community. Not excitement, not fear, recognition. It wasn't about aliens. It was about connection between what burns and what endures, between chemistry and consciousness, between the way the universe moves and the way we listen. In late November, when the data was compiled for public release, the report was understated. Comet 3IATLAS displays an unexpected chemical transition likely due to deep solar heating. Increased H2O sublimation observed. CO2 outgassing in decline. Dry words for a living miracle. But hidden within those sentences was something far bigger, proof that even a body born between stars could still learn to adapt under a foreign sun. The footage that followed was stunning. Solar orbiter captured jets firing like breath-fine white mist expanding into space, each burst timed with rotation. Slow-motion replay showed the glow expanding, shimmering, fading, like the rise and fall of lungs. Viewers across the world watched in silence. Some called it the comet that learned to breathe. Others simply watched and felt something they couldn't name. Because the truth is, this wasn't just science, it was reflection. We had watched a frozen relic thaw, and in doing so, it reminded us that even things that travel through the void still respond to warmth. Meanwhile, deep in the Nordic Observatory, a researcher reviewed the last CO2 data. He highlighted the final drop, a clean, symmetrical decline to zero, and sat back. The graph looked like a heartbeat finally slowing to rest. He thought of all the other comets that had come and gone, countless, anonymous, predictable, and yet this one had been different. It had arrived as carbon. It was leaving as water. And somehow that felt like progress. Maybe evolution doesn't belong only to life. Maybe even the lifeless find ways to grow. As December dawned, 3IATLAS moved past Venus's orbit, fading into the distance once more. Its brightness dimmed, its voice softened, but its legacy, that shift from CO2 to H2O, became one of the most poetic transitions ever recorded in astronomy. Because in a way, it mirrored us. We too are creatures of carbon who discovered water. We too were once cold, unknowing travelers until a star taught us how to speak. If you look up now, you won't see it anymore. It's gone back into that dark silence between stars. But the trail it left behind isn't dust or light. It's understanding. And understanding, once born, doesn't fade. The comet didn't just survive the sun, it changed because of it. Maybe that's all any of us ever do, collide with light, change shape, and drift onward carrying warmth we didn't have before. When a Harvard professor assigns a number to wonder, the world listens. 40%, that was the figure Avi Loeb gave when asked how likely it was that 3IATLAS wasn't natural. Not a vague maybe, not a cautious we don't know, a number, solid, measurable. And with that number, the quiet halls of academia began to tremble. It started with a conversation, a journalist asking a question half in jest. "Professor, if you had to bet, what are the odds this thing is artificial?" Loeb leaned back, smiled faintly, and said, "About 40%. The reporter blinked. 40. Not 4, not 1, 40. In a world where certainty is currency, 40 felt extravagant. It was an invitation and a challenge. The clip spread across social media in hours. The headline wrote itself, "Harvard astrophysicist, 40% chance, 3IATLAS is alien." The nuance vanished. The word chance became proof. The conversation became controversy. At the Center for Astrophysics in Cambridge, sunlight filtered through the tall windows of Loeb's office. The shelves overflowed with papers, black holes, early universe radiation, theoretical models of cosmic inflation. But on that morning, every conversation in the hallway turned to one thing. "Did you see what he said? 40%? He's lost his mind." Or maybe he just said what we're all afraid to think. In science, courage can look a lot like recklessness, but Loeb had built a career out of walking that line. He wasn't a provocateur by nature. He was a builder of equations, of theories, of bridges between the possible and the provable. His argument wasn't that 3IATLAS was artificial, it was that the evidence didn't rule it out. The anti-tail, the CO2 anomaly, the perihelion blackout, each one improbable on its own. Multiplied together, they looked almost designed. He wrote, "If we refuse to consider extraordinary explanations, we risk missing extraordinary truths." Some applauded his openness. Others saw arrogance, the sin of speculation in a field that prizes restraint. Have you ever believed something not because you were sure it was true, but because you couldn't bear to ignore it? That's where Loeb stood. He'd spent decades watching the universe through data, the faint whispers of light across endless time. But 3IATLAS was different. It wasn't just light, it was behavior. The way it entered the solar system along the ecliptic as if it knew the route. The way it mirrored Oumuamua's angle. The way it seemed to time its closest approach with the sun's blinding presence. Each fact alone could be coincidence. Together they felt like intent. At first, few colleagues responded. The silence wasn't rejection. It was distance, the kind that scientists use when a topic starts smelling of headlines. Then came the backlash. An editorial in Nature speculation without evidence harms the discipline. A blog post by a NASA researcher, Avi Loeb, is doing SETI no favors. Tweets, memes, debates. Someone even edited his Wikipedia page to read famous for believing comets might be spaceships. And still, he wrote. In his blog entries, Loeb posted updates daily, calm, methodical, even hopeful. Science, he wrote, is not about consensus. It's about curiosity, disciplined by evidence. But curiosity has a cost. In late September, Loeb appeared on Joe Rogan's podcast. 2 hours of cosmic talk, black holes, light sails, and the 3IATLAS hypothesis. Millions watched. Clips went viral. One soundbite stripped of tone and context burned through the internet. If you want to take a vacation, take it before October 29th. It was a joke, a playful nod to perihelion, but the internet doesn't do tone. It does fear and fascination. Suddenly, Loeb wasn't just a scientist. He was a symbol of defiance, of curiosity, of danger, depending on who you asked. The irony, he never claimed certainty. He claimed humility, the willingness to admit we don't know. But humility rarely trends. Certainty does. Within weeks, thousands of videos appeared analyzing every frame of his interviews. Some praised him as the Galileo of our time. Others mocked him as the clickbait professor. A few just listened and asked the right question. Why do we fear being wrong more than we crave being right? At Harvard, Loeb taught his usual lecture on exoplanetary dynamics. The students filled the hall, their notebooks, ready eyes eager. He began as he always did, quietly. Imagine, he said, you are on a beach. You find a bottle. Inside is a message. You don't know who sent it or why. Would you throw it back to sea, or would you open it? He let the silence breathe. That, he said, is the 3IATLAS question. Meanwhile, astronomers across the world continued to gather data. The comet's motion was normalizing. The tail had realigned. Spectra confirmed the CO2 transition was natural. Each finding chipped away at the extraordinary. Each piece of evidence suggested the universe was just being itself. But Loeb's 40% lingered. Not as a number, but as a challenge. What does it mean when a scientist dares to measure wonder, to quantify awe? Maybe that was the real gamble. Not that 3IATLAS might be artificial, but that belief itself could be an experiment. Science isn't immune to emotion. Every equation begins as a feeling, the sense that something should make sense. And sometimes that feeling outruns the data. In December, the comet re-emerged in post-perihelion images, intact, dimmer, ordinary. No thrust, no signals, no deviation. Natural after all. Reporters flooded Loeb's inbox. So, were you wrong? He replied with a single sentence, being wrong is how we find what's right. The story faded from the news cycle, but not from memory. In the end, the number 40% wasn't about probability. It was about permission. Permission to look up and wonder. Permission to ask questions that sound ridiculous until they don't. Permission to let the universe be strange again. And maybe that's what makes science beautiful, not the answers, but the courage to ask when everyone else has stopped. Because one day, whether it's the 4th or the 50th interstellar visitor, one of them might whisper back, And when it does, we'll remember that once someone dared to say, "What if?" When Loeb left his office that winter evening, snow was falling over Cambridge. He paused on the steps, looked up, and smiled. Somewhere out there, 3IATLAS was still moving, smaller now, fainter, but not gone. He whispered, "Thank you for the conversation," and disappeared into the snow. And above him, unseen through the clouds, a single point of light drifted farther into the dark, silent patient, unafraid. There's a strange gravity to belief. It bends everything around it, logic, memory, even truth. Once 3IATLAS became a story, not just an object that gravity took hold. At first, it was simple: one comet, one mystery. But by the time it passed behind the sun, it had already become a mirror. People no longer looked at it. They looked through it and saw themselves. Across the world, the algorithms began to hum. Search engines, social feeds, video platforms, all calculating what we wanted to see. A thumbnail of a bright comet, a caption in bold red letters, NASA hiding the truth. And with one click, the future of 3IATLAS was sealed not in data, but in narrative. The algorithm didn't care about science. It cared about emotion. It learned within hours that fear travels faster than facts. Curiosity kept you for 30 seconds. Panic kept you for 10 minutes. Have you ever noticed how the stories that scare you feel more real? That's not coincidence. It's computation. By October, millions had seen some version of the 3IATLAS story that wasn't real. Deep-faked scientists, fabricated NASA memos, clips stitched from interviews, mouths moving to words never spoken, and behind every upload, a pattern-optimized engagement. The truth was simple, verifiable, even beautiful: a comet rich in CO2 that revealed water under solar heat. But the algorithm didn't amplify simplicity. It amplified uncertainty. The stranger, the headline, the faster it spread. The more shocking the claim, the higher it climbed. It was no longer a telescope that shaped our view of the universe. It was a recommendation system. Inside actual observatories, the contrast was surreal. While the internet screamed, scientists watched silent streams of numbers, graphs, stable orbits. No miracles, no catastrophes, just physics. But outside those walls, wonder had been weaponized. Could this be proof of life? Was Harvard told to stay silent? Did NASA see something during the blackout? Each question multiplied, shared, reshaped, repeated, and each repetition made it feel truer. Repetition is its own kind of gravity. The more we orbit an idea, the harder it is to leave. In one viral video, a popular creator whispered over dramatic music, "They say the comet was just ice. But what if ice remembers where it came from?" Millions listened because it felt profound, and feeling profound now counts as proof. The next morning, an astronomer posted a calm correction thread, citations, graphs, links to Soho data. It reached a few thousand people. It was beautifully reasoned and invisible. That's the new equation of truth, emotion, time, our reach, and science by nature takes time. Even within research communities, the algorithm cast shadows. Funding committees discussed how to communicate better. Press teams rehearsed how to preempt misinterpretations, as if truth needed marketing. But maybe now it does, because truth that moves slowly dies quietly. 3IATLAS had exposed more than a comet's secrets. It had exposed ours, how belief now propagates like light, bouncing endlessly faster than reason can follow. Have you ever changed your mind after believing something too strongly? Did it feel like falling or freedom? The internet rarely allows that fall. Once an idea goes viral, admitting doubt feels like betrayal. So we defend what we know even when we don't know it anymore. And in that defense, something beautiful gets lost: the humility to wonder. Meanwhile, at a small university in Finland, a graduate student named Mira was analyzing tail luminosity data from the anti-tail period. Her conclusion: everything matched known physics perfectly. She presented her paper online. One comment read, "She's part of the cover-up." No matter how clearly she spoke, her words bent under the same gravity as Loeb's The Gravity of Belief. When she looked out the window that night, she could see the comet faintly, a soft blur moving slowly through Cassiopeia. She thought, it doesn't need to be alien to be extraordinary. And for a moment she smiled, a quiet rebellion against the noise. By December, the data was complete. No unexplained thrust, no secret transmissions, just the beauty of natural physics at work. But by then the truth was irrelevant. The algorithm had moved on from comets to scandals to celebrity gossip. The digital storm had shifted skies. Only a few remained, still watching the object fade, still whispering its name. In the end, 3IATLAS taught us two things: how comets behave and how we do. One scientist wrote in his closing notes, "We may be the first species to create machines that know how to manipulate our curiosity before we do." He wasn't talking about aliens, he was talking about ourselves. The algorithm didn't invent belief, it just learned how to feed it. As the year closed, 3IATLAS passed beyond Jupiter's orbit, dim and slow. It would never return. But its echo remained not in telescopes, but in timelines. Because long after the light fades, the stories remain. They drift like dust, glowing faintly, carried by invisible currents. And maybe they remind us that in the search for truth, the hardest thing isn't what we don't know. It's unlearning what we want to be true. Look up tonight. There's no comet there now, only silence, only the quiet hum of a digital world still deciding what to believe next. And if you listen closely, you might hear it, that faint mechanical whisper beneath your scrolling thumb asking softly, what would you rather believe, the data or the story? By the time truth realized it was losing, it was already too late. 3IATLAS had left the inner solar system, but on Earth, the battle it sparked was only beginning, not in space, in screens, in voices, in trust. The first video appeared in late November. It showed a NASA press conference, familiar faces, official logos, crisp microphones. A woman in a blue blazer stood at the podium, her tone calm, professional. After careful analysis, she said, "We have confirmed an artificial signal embedded in the comet's radio reflection." The clip spread faster than any telescope alert ever had. It looked perfect, lighting, compression, mannerisms, even the subtle hand gestures of the spokesperson. But there was one problem. NASA never said those words. That conference never happened. The video was a deepfake, generated, edited, distributed within hours by accounts that weren't real either. Soon there were more. A version of Avi Loeb saying, "I've seen the evidence. They told me to stay quiet." A fabricated interview with Dr. Michio Kaku declaring NASA confirmed it privately. Even a speech from Brian Cox, his voice flawless, his face emotionless, claiming 3IATLAS isn't from here. Each clip was algorithmically engineered to trigger awe and fear. They didn't just imitate language. They imitated authority. And once authority could be copied, the war for reality began. Inside real laboratories, silence turned heavy. Emails flooded in. Is this true? Why won't you tell us? Are you lying? Scientists who had spent decades studying dust and spectra now spent days issuing denials. But denials never go viral. Truth moves at the speed of patience. Lies move at the speed of upload. Have you ever tried to erase a rumor once it's been digitized? It's like chasing light with your hands. The platforms reacted slowly, cautiously. Fact-checkers flagged videos. Banners appeared may contain synthetic media, but the copies multiplied faster than they could be labeled. thousands of re-uploads, millions of views. By December, the line between science communication and digital mythology had vanished. Even journalists struggled. They'd watch a clip, pause, rewind. Is that real? Was this the original? Who posted first? It was no longer about content. It was about source decay. When every truth can be mimicked, the only thing left to believe is emotion. In a small office in Geneva, an astrophysicist named Rajiv scrolled through endless threads of false footage. He'd spent years studying cosmic dust at CERN's particle lab. Now he was studying human dust, the residue of misinformation. He whispered to himself, "They don't even need to fake stars anymore. They just fake us." He opened a real data set, faint green lines tracing CO2 emissions, H2O balance, trajectory, stability. Everything normal, everything beautifully normal. He sat back and stared at the graph, quiet, steady, sane. Outside his window, the Alps were covered in snow. Above them, no comet, just silence. Meanwhile, on YouTube, a new video surged, titled NASA Shutdown. The truth they found inside 3IATLAS, the thumbnail a glowing blue comet with a digital face hidden inside the tail, eerie music, AI narration, perfectly paced. 80 million views in 3 days. Comments scrolled like a storm. I knew it. They're hiding everything. This is proof. A proof built from pixels and persuasion. Have you ever wondered what happens when we stop being able to tell who is speaking? That's where humanity found itself, not at the edge of the universe, but at the edge of understanding. Deepfakes blurred lines so thoroughly that truth fatigue set in. People stopped checking, stopped questioning, stopped caring. Because disbelief, too, can be a form of surrender. Back at Harvard, Loeb received an email with a video attachment. He opened it, watched himself on screen, his voice, his gestures, his office saying words he never said. We've decoded a message hidden in the comet's rotation pattern. He stared at it for a long time. Then he smiled, not in amusement, but in resignation. This, he whispered, is how legends begin. He closed the laptop. The following week, the European Space Agency issued a formal statement. No evidence of artificial components or communications has been found in data from 3IATLAS. All observed phenomena are consistent with known natural processes. It reached maybe 1% of those who'd seen the fake videos. The rest had moved on to a new headline, a new myth, a new lie wearing science's skin. By mid-December, new deepfakes appeared not of scientists, but of viewers. Ordinary people, teachers, students, parents fabricated testimonials. I worked for NASA. I saw the raw footage. I decoded the sound myself. Each one more believable than the last because the best lies are told by faces that look like ours. The deepfake war wasn't just about technology, it was about trust as a finite resource. Every image chipped away at the fragile bond between those who see and those who know. And yet, amid the static, one small video slipped quietly into the stream. No music, no edits, no voice filters. A telescope feed, live and raw. Just a pale dot drifting against the stars. Its description read, 3IATLAS final sighting before solar fade. It had only a few hundred views, no comments, no noise, just truth unembellished, unseen, unviral. And maybe that's where truth belongs now, not in headlines, but in quiet spaces where no algorithm hunts it. Have you ever thought that maybe truth survives, not because it wins, but because it waits? The comet was gone. The videos were endless. But somewhere inside all that chaos, someone still looked up and whispered, "It was beautiful, even if it was just ice." Truth doesn't vanish. It only hides until we remember how to look without fear, and when we do, maybe we'll see again. Because in the end, 3IATLAS didn't teach us about the stars. It taught us about ourselves, how easily we mistake reflection for revelation. and how sometimes the deepest war isn't between nations or machines, but between truth and belief inside the human mind. It began quietly. No alarms, no sudden alerts, just a gap, a missing update on the NASA website that people expected but never arrived. For months, the 3IATLAS mission had streamed data openly. Telemetry charts, brightness reports, trajectory projections, a slow rhythm of numbers that gave the illusion of control. Then, on October 1st, the rhythm stopped. The United States government had shut down. Budgets frozen. Communication suspended. Thousands of researchers furloughed overnight, sat at home staring at blank monitors that once connected them to the stars. In Houston, lights still glowed inside Mission Control. Screens stayed on, but voices were gone. You could almost hear the silence echoing down the corridors, a silence filled not with rest, but with static. Outside, the sun burned as usual. 3IATLAS moved on unseen, unstoppable, and as the comet approached its perihelion, public curiosity peaked right when official communication went dark. The timing was too perfect. Conspiracy threads lit up instantly. NASA shut down to hide something. Data blackout equals cover-up. It didn't matter that the truth was bureaucratic and boring perception had already taken its own orbit. But in observatories across the world, the work never really stopped. ESA-JAXA, even small university telescopes in Chile and South Africa, they kept watching. They saw the light curve, dip, rise, shift, but nothing supernatural. Just physics doing what physics always does, beautifully indifferently. And yet, for the public, silence had a flavor. It tasted like secrets. Because in the absence of information, imagination becomes evidence. On social media, the rumor storm intensified. Anonymous accounts shared leaked memos, fake screenshots of classified imagery, voice clips of scientists warning of an approaching object, all fabricated, all convincing. NASA's official channels remained frozen. No tweets, no press releases. Even the Jet Propulsion Laboratory's live feed, normally a stream of harmless telemetry, displayed only a single line. System maintenance in progress. To the patient observer, that sentence meant nothing. To the restless mind, it meant everything. And so the narrative grew that the government had seen something in the data, that the comet's trajectory wasn't natural, that the timing of the shutdown coinciding with 3IATLAS's closest solar approach was no coincidence. Videos appeared dramatic cinematic, often set to ominous music claiming NASA knows, but the scientists themselves were powerless to respond. Emails went unanswered, public comment threads filled with noise, and the world waited suspended between fact and fiction. In the stillness, a new pattern emerged. It wasn't the silence of conspiracy, it was the silence of structure. The same silence that hums between planets, the pause before new data arrives. Inside the Jet Propulsion Laboratory, essential systems remained active. The engineers still checked trajectories, still tracked radiation output, but none of it reached the public. The light was on, but the window was closed. For 2 weeks, 3IATLAS was hidden behind both the sun and bureaucracy, and the human mind filled that void with ghosts. Meanwhile, the comet continued its slow arc toward the solar horizon. Its signal weakened, drowned in radiation. Every telescope, every sensor strained against the brightness and failed, not because of any cover-up, but because the universe simply doesn't care about our timing. When the government finally reopened the first data, uploads came through like a flood. Hundreds of files queued, time-stamped, delayed, harmless. The world refreshed their browsers and waited for the extraordinary. What they found was the ordinary made miraculous by absence. Charts, tables, Brightness returning, trajectory normal, no alien signatures, no sudden deflection. Just the simple, humbling truth we had been blind because of light, not because of lies. But something else had changed in those 2 weeks. Trust. The shutdown had exposed how fragile communication was, how easily silence could mutate into suspicion. In the vacuum of official voices, the loudest stories had won. And so when NASA finally spoke again, the words felt strange, measured, careful, each phrase dissected online within minutes. But behind the noise, the real story glowed steady. 3IATLAS was still there. It had survived its dance with the sun. It had emerged from the light, smaller, darker, but intact. The images from SOHO and Solar Orbiter showed a smudge crossing the corona. Beautiful, predictable, human. Because in that silence, the one filled with fear, invention, and longing, what the world really discovered wasn't a secret. It was how much we hate not knowing. And maybe that's the lesson the universe keeps trying to teach us, that the unknown isn't proof of deception, it's an invitation to look closer. It started with a question that no one could ask out loud. Where were the pictures? When 3IATLAS passed near Mars, the Chinese Tianwen-1 orbiter was in the perfect position to capture it. Every mission log confirmed its line-of-sight trajectory timing, yet, as days turned into weeks, nothing appeared on any public feed. No new images, no public statements, just silence. People noticed. The online astronomy forums lit up instantly, not with anger, but with curiosity sharpened into suspicion. If every other space agency had shared something, a grainy image, a spectrum, a light curve, why was the nation with the clearest vantage point the quietest? Theories bloomed like frost across glass. Perhaps the cameras malfunctioned. Perhaps the bandwidth was reserved for higher priority operations. Perhaps something was seen that shouldn't be shared. But in truth, the answer might have been far less cinematic. Space agencies hold images until they are verified, cataloged, cleared through internal review. Even a single bright pixel misplaced can ripple through data integrity like a crack in glass. Yet the delay came at the worst possible time. The world was watching. NASA had just emerged from its shutdown. The European Space Agency had released faint corona images, barely useful, but proof of life. And China, silent, appeared to be withholding something extraordinary. On social media, this silence evolved into a language of its own. Screenshots of leaked data falsified, clips of analysts claiming to have decoded satellite telemetry fabricated, and yet each falsehood felt more convincing than the truth that nothing was there. Inside laboratories, scientists continued their work heads down patient. They analyzed solar radiation, magnetospheric data, particle counts, trying to determine whether the comet had changed shape near perihelion. Every variable led to the same conclusion: stable, predictable, uneventful. But the myth was already stronger than the math. In a small observatory in Qinghai, one researcher wrote quietly in a logbook, "There is beauty in what is missing. Silence is also a kind of data." The public never read that line, but if they had, maybe they would have understood that sometimes the absence of evidence is not mystery, but restraint. Weeks passed. Then, without announcement, a series of unmarked image files appeared in the International Data Archive. No captions, no metadata, just timestamps. They showed a small, faint object against the Martian horizon 3IATLAS, reduced to a pin of light, drifting between dust storms. It was there all along, exactly where the predictions said it would be. There was no alien structure, no unnatural glow, no broken laws of physics, just a comet, ancient, indifferent, continuing its path. But something in those frames lingered. The composition, the stillness, the scale. It wasn't scientific data anymore. It was art, a reminder that distance doesn't always mean detachment. When the images were finally verified by the global network, they entered the record quietly, without ceremony. Most people had already moved on to newer theories, brighter rumors, louder noise. But in that quiet corner of the archive, truth lived like a candle in vacuum, fragile, persistent, waiting for eyes willing to see simplicity again. If you were to look at those frames, now tiny streaks of light across Mars's orange haze, you might not feel wonder, but something smaller and deeper, a kind of humility that only silence can teach. Because in the end, China's missing images were never truly missing. They were simply waiting for the world to be quiet enough to notice. It began as data. Simple graphs, light curves, numbers scrolling across a quiet screen. But somewhere between transmission and translation, truth fractured. 3IATLAS had left the sun behind. Its orbit was stable, its light diminishing, its mystery for the moment resolved. And yet on Earth, a different kind of brightness was spreading, the glow of a billion screens each, telling a different version of the same story. In one video, the comet had exploded. In another, it had changed direction. In others still, it was no comet at all, but a ship, a signal, a warning. Each clip more confident than the last. Each explanation louder, sharper, more certain. The algorithms rewarded the boldest voices, not the truest. The faster the fear, the stronger the reach. And slowly, the science was drowned beneath the sound. It didn't happen overnight. First, the official channels were questioned, then the experts themselves. Finally, even the idea of evidence began to feel negotiable. One image of 3IATLAS was reused, recolored, claimed by hundreds of channels. Some called it proof of alien craft, others proof of government secrecy. Few stopped to ask what it really was. Sunlight reflected on dust, but people were tired of dust. They wanted revelation. And the internet is very good at giving people what they want. Comments turned to certainty. Certainty turned to faith. Faith turned into armies of keyboards defending beliefs built from pixels. Somewhere between fascination and fatigue, truth lost its shape. In a small lab in Arizona, a data analyst watched the chaos unfold on her second monitor, while her first continued plotting brightness decay. The numbers were calm, elegant, predictable, the world around them not so much. She didn't speak, didn't post, didn't argue. She simply watched the curve flatten slowly into the kind of silence only math can make. Outside headlines screamed, "Comet vanishes after secret experiment." Government quietly deletes 3IATLAS data. Astronomers admit they lied. All fiction, all louder than fact. But even lies have orbits. They move fast, at first bright with outrage, before drifting outward into irrelevance. Truth, meanwhile, moves slower, heavy with gravity, but it endures. Weeks later, the real post-analysis report went live. It was quiet, understated, a PDF on an academic server. No music, no narration, no sensational title, just numbers, equations, residuals, graphs, and a simple line at the end. No evidence of artificial origin. Observations consistent with interstellar cometary behavior. Few read it, fewer understood it, but for those who did, it felt like oxygen. Because in an era where everything could be forged, voice, image, truth itself, the real miracle wasn't that 3IATLAS came from another star. It was that reality still existed, even when no one was listening. The comet was never trying to deceive us. We deceived ourselves by mistaking belief for proof and noise for knowledge. If you closed your eyes, though, and listened closely, you could still hear the universe whisper through the static that patience is the language of truth. That silence isn't the enemy of meaning, it's the birthplace of it. Because every time a comet fades from view, What we're really left with is a mirror reflecting how we choose to see. When the noise finally faded, what remained was data cold, beautiful, stubborn. Numbers don't argue. They don't believe. They just exist. And for all the noise that had surrounded 3IATLAS, the data itself whispered a quieter kind of mystery. In every major observatory from Mauna Kea to La Palma, analysts began reprocessing the archived measurements, spectral lines, dust density, outgassing ratios. Everything that could be plotted was, everything that could be compared was compared, and something small but unshakable refused to align. It started with the ratios of CO2 and H2O, a balance that should have changed predictably as the comet neared the sun. Instead, the carbon dioxide stayed higher longer than any known model could explain, not by much, just enough to make every equation slightly uncomfortable. At first, it looked like a calibration error, a misplaced decimal, a rounding anomaly. But the pattern repeated across instruments, across hemispheres, across time. Different telescopes, same result. It wasn't wrong, it was just different. And in science, different is the first heartbeat of discovery. The anti-tail, once thought to be an optical illusion, now seemed connected to this chemical imbalance. CO2 jets erupting in strange directions, pushing dust backward instead of outward. It shouldn't happen not under standard solar wind pressure, and yet it did. One research team proposed that 3IATLAS's internal structure might be porous, honeycombed with channels where volatile gases escaped unevenly. Another suggested its spin axis might be tilted just enough to redirect outgassing like a sprinkler twisting in the dark. Each explanation worked until it didn't. For every graph that fit, another broke. For every elegant equation, a rogue data point. The physics were close, painfully close, but never perfect. It reminded many of Oumuamua, the first interstellar visitor. That one, too, had refused to behave. It changed speed without visible thrust. It reflected light unevenly, as if coated in metal. And when it left behind more questions than comfort. Now, years later, the same unease returned. Different object, different trajectory, same whisper, something doesn't add up. But this time, scientists were ready to listen without reaching for miracles. No talk of alien sails or artificial design, just patience, humility, and math. At the European Southern Observatory, a postdoc spent nights layering data sets from 6 observatories, aligning timestamps down to the millisecond. The light curve wobbled not much, just enough to hint at rotation with subtle irregularity. A pattern emerged every 57.2 hours, a small but measurable dip. A spin cycle maybe, or something else entirely. If 3IATLAS was tumbling, its jets might pulse unevenly, explaining both the brightness changes and the off-angle tail. But that, too, led to another question. How had the object held that spin for so long, traveling light years, crossing the interstellar medium, being bombarded by dust and radiation, and still the same rhythm unbroken? It was as if the comet carried memory in its motion. Some models suggested internal layering ice carbon, silicates all compressed into crystalline density. Others pointed to magnetic coupling, the subtle dance between charged dust and solar fields. None fully satisfied. Every answer opened a smaller, sharper question. And that is what made 3IATLAS special. It refused to fit neatly into our drawers labeled known. Science thrives on what doesn't fit. Every mystery is a crack in the surface of understanding, an invitation to look closer, not a reason to panic. By late October, the final consensus report was released, not with drama or secrecy, but with the quiet dignity of real work done well. Hundreds of pages, dozens of contributors, no certainty, just precision. The conclusion read simply, outgassing dynamics of 3IATLAS show partial deviation from standard cometary behavior, no violation of physics observed. Partial deviation, the most poetic phrase a scientist can write. It means the world is stranger than we thought, but not beyond reach. When astronomers plotted the final path, it formed a graceful arc through the inner solar system, threading perfectly between orbits like a needle drawn by invisible hand. By the time it crossed Jupiter's line, it had begun to fade, tail dissolving brightness, softening energy returning to quiet. But one small peculiarity remained. The last radar echo captured by a deep space array in Spain showed something odd, a phase delay too long for its distance. Not error, not interference, just time behaving slightly stretched. Maybe it was dust density, maybe a refractive glitch, maybe a reminder that even the speed of light, absolute as it seems, can still surprise us in practice. The papers were careful not to overstate, but between the lines a feeling persisted that the laws of physics had been brushed, not broken. Sometimes progress doesn't come from what we prove, but from what refuses to sit still inside our equations. As 3IATLAS drifted back toward the dark between stars, the world grew quieter again. The headlines had faded, the debates had burned out, and the scientists, those who stayed long after the excitement, returned to their instruments, their data, their patience. No one called it a miracle. No one called it a message. They just called it what it was, a reminder that the universe still has room for small, precise astonishments. Far beyond the reach of telescopes, the comet continued its slow rotation, carrying with it the fingerprints of physics slightly undone. A fragment of order lost to the wildness between suns. A mystery not to be solved, but to be remembered. For weeks, the sun had been a curtain too bright, too wide, too dangerous to look behind. And then, one morning in mid-November, that curtain lifted. A single observatory in Chile was the first to see it. A faint smear of motion on the edge of dawn, small, pale, almost shy. But there it was. 3IATLAS had returned to the sky. The silence that had followed perihelion broke all at once. Telescopes around the world turned in unison. The data streams came alive again, coordinates, timestamps, spectral lines. After 23 days of blindness, the universe had reopened its eyes. At first, no one dared to speak. The object's brightness was lower than before, its tail longer, thinner, like something exhaled rather than burning. The instruments showed a gentle wobble in trajectory, nothing dramatic, but enough to keep hearts racing. And then a frame appeared, not from Earth, but from a satellite that had been watching the sun's limb. A white speck moving out of shadow, surrounded by a faint halo of dust. Its shape was intact. Its color had changed. Not the cold gray of frozen stone anymore, but a softer hue tinged with blue-white light, like ice that had learned how to glow. The astronomers didn't cheer. They just exhaled slowly, collectively, as if the entire world had been holding its breath. The data confirmed that 3IATLAS had survived the sun. Have you ever felt that moment when relief becomes awe? When the thing you feared might vanish instead shows you it was stronger than you imagined. That's what the night of November 17th felt like. Across observatories, people who had not slept in days sat quietly before their screens. Outside, the air was thin, electric, full of something unspoken. Not discovery, not victory, but recognition. For all our instruments and algorithms, what we had really been waiting for was proof that nature could still surprise us. The new readings showed subtle changes. The CO2 jets that once dominated were fading, replaced by gentler streams of water vapor. Surface composition, shifting temperature, falling a body cooling after a near-death encounter with fire. And yet there was more. A secondary plume trailing behind the main tail, faint but persistent like a ghost following its own body. It didn't fit any known model. Some called it an aftershock residual gas escaping from cracks made during perihelion. Others saw pattern rhythm order. Every time the object rotated, the secondary plume brightened, then dimmed again. Pulse, pause, pulse, a heartbeat of ice and sunlight. When the data reached the public, the conversation reignited. Proof it changed. Proof it lived. Proof it wasn't natural after all. But those who had watched from the start no longer needed conspiracy or certainty. They had seen something much quieter, how reality shifts shape when you wait long enough. In a small control room, a technician compared the first image from April to the latest frame, the same comet, two faces of the same traveler, the first distant, untouched, the second scarred, glowing alive. Between them lay everything we didn't see: the darkness behind the sun, the silence of observation, the faith that looking away doesn't mean losing. And somewhere in that silence, humanity had changed a little too. Because the real story of 3IATLAS wasn't what it was made of or where it came from, but what it reminded us of. That mystery isn't a flaw in science, it's its engine. That sometimes the clearest signal comes after the static. As the days passed, the comet drifted outward again, dimmer now, retreating into the background of stars. But its orbit left a trail of questions more luminous than any tale. Was this how knowledge always works? A brief flare of light in the dark, brilliant, fleeting, impossible to forget. And somewhere beyond our reach, the comet kept moving, no longer defying the sun, no longer hiding from it, just continuing. That was the moment of clarity. Not in the data, not in the graphs, but in ourselves, realizing that what we chase isn't always truth itself, but the feeling of finally seeing. It is strange, isn't it, how something can arrive, pass through, and then leave, yet the space it touched is never the same again. 3IATLAS was gone now, a faint trace on a chart, a dim echo on spectrograms, but in the silence it left behind, the world was still listening. For months it had been the mirror we held up to the universe, and in that reflection, we saw more than ice and dust. We saw how deeply we long to understand what moves through the dark, and how fragile our own light looks beside it. When the data stopped coming, the world didn't. It just shifted. Articles turned to archives, hashtags faded, and the telescopes returned to their usual work, watching ordinary comets do ordinary things. But something had changed, not in the sky, in us. In classrooms, new projects were proposed. In quiet offices, researchers began re-examining the spectra, not for proof of alien craft, but for subtler things: isotopic ratios, grain density, the fingerprints of another sun. Each number told a story of a system not like ours. A place where carbon breathes differently, where ice burns at another rhythm, where time itself flows colder. It wasn't about mystery anymore. It was about belonging. Because when you track something that has crossed between stars, you realize sooner or later all matter travels, even us. Have you ever thought about that? That the oxygen you breathe tonight may have been born in another world? That your bones remember collisions older than Earth? That every comet, every grain of dust, every thought is just the universe trying to know itself a little better? 3IATLAS didn't change physics. It changed perspective. It showed that science is not the opposite of wonder. It is how wonder grows up without losing its voice. In the years that followed, its trajectory was modeled again and again, each simulation ending the same way: a curve into the dark, a slow fade into interstellar silence. But just once in a late-night analysis run, a researcher noticed something small, a deviation in expected velocity. Tiny, meaningless maybe, but enough to make her look twice. The curve bent not away from the sun, but towards something else deeper in the dark. She smiled, saved the file, and didn't tell anyone. Some truths are better left unspoken until the world is ready. And maybe that's what the comet was all along, not an answer, but a question we didn't know how to ask. Because what if we were never meant to understand everything? What if we were only meant to look up, to listen, to learn what silence sounds like between the stars? The universe doesn't hide its secrets. It waits for us to quiet down enough to hear them. And if you listen right now past the hum of power lines, past the noise of news and fear and endless chatter, you might still hear it. That faint whisper that began the moment 3IATLAS passed behind the sun. A low distant pulse, steady, patient, like a thought that has learned to travel. Maybe the comet isn't gone. Maybe it's just continuing its sentence. And maybe in the next century, another piece of that story will drift our way again, bright enough to remind us who we are when we remember to look.